So we looked at the equations of motion, and so if there's three of them, okay, and then we have these letters. V is the final velocity, U is initial velocity, A is acceleration, T is time, S is displacement, okay. And we're trying to sort of understand where they come from and what they mean. So we said it's very important to know the context of these equations, and the context is that they're for a moving object or a point moving in a straight line, okay? There's no two-dimensional, three-dimensional things happening. It's really a one-dimensional thing. Things are moving back and forth along a straight line, moving forward in a straight line, moving in one dimension, okay? And so that's very important, okay? And maybe something that could remind you of that is this third equation, okay? It does not make sense to square vector quantities, okay? So something happened here that was kind of weird if velocity really is a vector. You know, you could take maybe the dot product of vectors when you learn that, but to square a vector doesn't really make sense. But in one dimension, a vector is really just the same as a number with a sign, okay? Because in one dimension, you can only be in the plus direction or the minus direction. So you could use a plus or minus sign to represent the direction, and then it's just a number with a sign, and you can square those, okay? So we talked about that. And so what is the first equation of motion? Well, the first equation of motion is really just saying, well, it's not really an equation of motion. It's just that really part of the context again. We're saying that we're in the situation of constant acceleration as well. Okay, so what does that mean? It means if you know the initial velocity, this is why it has initial and final. If you know the initial and final velocities, then because it's constant acceleration, you'll know what all the in-between velocities are. Okay, and that's what it's telling you. So if it's constant acceleration, it means the slope on the velocity versus time graph is constant. So it's a straight line, okay? And to find the acceleration, you can just find the slope, and you see the acceleration when it's constant is just the final velocity minus the initial velocity over time. That's how you find a constant acceleration. It's the same as the average acceleration, and if you just rearrange this, you actually get the first equation of motion. If you rearrange the first equation of motion, you get that. So the first equation of motion is just equivalent to saying that we're talking about a situation with constant acceleration. The second equation of motion, okay, so remember how we said the derivative of S is equal to V. If you actually learn derivatives, maybe you can review this after you learn derivatives. The derivative of this is the sum of the derivatives, and what happens is the derivative with respect to t, like a power of t, it just reduces in power by 1, and the old power times at the front. So this is times by 1, and it reduces to 0, so it just becomes u. This one, the 2 comes to cancel the half, and then t squared becomes t to the 1, so it becomes at. So actually the derivative of 2 is actually 1. Well, the antiderivative of 1 is 2. So 2 is not really a new it's not really a new equation of motion. And I guess we're assuming it's the displacement that's happened starting from time equals 0 to time equals t. Okay. And a question that came up was, how do you measure, say, the acceleration due to gravity on the surface of the Earth if it was constant? And so what you could do is you could maybe drop a ball from a certain height that you know the height. You could time how long it takes. You know it starts from rest, so u equals 0. And then you have all the unknowns except for a, which is the acceleration due to gravity. And then that's your way of calculating something like that. Okay. And then we said the third one is actually just the consequence of the first two. Because because if you make t the subject in 1, and substitute it in here, removing all the t's and replacing it with the expression we got, then it'll simplify this. Okay, and you can maybe do that as an exercise. You already did that as an exercise. Okay. So that's really all there is to the equations of motion. It's really a complete description of the motion. So when we say complete, we really mean we know basically everything about its velocity, acceleration, and its position. For a moving object in a straight line. Okay. So a constant with constant acceleration, the acceleration maybe could change, and then we don't have a complete description. We'd have to figure out how the changing acceleration affects everything. And if you know calculus, it's basically calculus.